Welcome to Eureka Math. This is lesson 20 and our objective today is to use coordinate systems to solve real world problems. Guess what, everybody? This is the last lesson for our school year, and the final exam will be our Module 6 end of unit assessment, and then we'll have summer break. It's exciting. So let's get into this, and our objective today is to use coordinate systems to solve real-world problems. When you see that real-world problems, you know that means story problems. Okay, so let's go to our Learn Book page. I don't know what page it is, but lesson 20, problem set. Put your name on your paper. The line graph below tracks the total tomato production for one tomato plant. Okay. The total tomato production is plotted at the end of each of 8 weeks. Use the information in the graph to answer the questions that follow. Now after this, you guys are going to all plant tomatoes in your garden for the summer, right? Or on your balcony or in your living room. How many pounds of tomatoes did this plant produce at the end of 13 weeks? So the graph only goes up. So at the end of 13 weeks, which is right here, this is 13 weeks, there were how many tomatoes in pounds? 10 pounds. This is one plant. This is a super plant. Okay, did this plant produce at the end of 13 weeks? 10 pounds. Please use your labels. B, how many pounds of tomatoes did this plant produce from week 7 to week 11? So week 7 is here, and week 11 is here. So we're starting with 1, 2, 3 pounds, and we're going to 9 pounds, right? So we're going to subtract 9 pounds minus 3 pounds equals 6 pounds. Okay, explain how we know. Well, we subtracted from here to here. We just subtracted that amount, which was, and we could just do this fun thing here, 1, 2, 3, 4, 5, 6 pounds. Okay, and I just go across like that. That'll show you. All right. Which 1 week period showed the greatest change in tomato production? Okay, the greatest and the least, and explain how you know. When it just says the least, it's asking you the same question, but instead of the greatest, it means the least. So the greatest change in plant production was, where's the biggest change? So from here to here, from here to here, from here to here. Oh, from here to here, that is the biggest jump right there. That's the big jump from week 9 to week 10. So the greatest change was week 9. The least, and the least is where it's going to move move less. And I can see that right here it didn't change at all, did it? From week 11 to week 12. So there was no change at all, didn't produce anything. Poor plant. Week 11. And how do we know? Well, we know because the graph didn't change. Okay, so here, how do we know the graph jumped the most? And here, the graph didn't change. During weeks 6 through 8, Jason fed the tomato plant just water. From 6 through 8, just water from here to here. Okay. During weeks 8 through 10, he used a mixture of water and fertilizer. Oh, we have a big jump there. That's the water and fertilizer. H2O is our symbol for water, right? Plus fertilizer. I'm just going to put fertilizer like that, fert. And from weeks 10 through 13, he used water, fertilizer A. And weeks 10 through 13, he used water and fertilizer B. So fert A. And here, water and fertilizer B. Okay. Compare the tomato production of these periods of time. Well, from here we went about 1.5. Would you say that's 1.5 pounds up to 3.5 pounds? So that was 2 pounds during that first week. Two pounds of production. Then weeks 8 through 10 had, let's see, 3.5 all the way up to 8.5. So 8.5 minus 3.5 is 5. So 5 pounds that week. Wow. And fertilizer B, week 10 through 13, went from 8.5 to 10, which is only 1.5 pounds. So I think we can say fertilizer B, or fertilizer A, works. Good. Okay, use the story context below to sketch a line graph. Then answer the questions that follow. The number of 5th grade students attending Magnolia School has changed over time. The school opened in 2006 with 156 students. So let's see, this is 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Okay. So from here to here we have 60, 70, no, that's not right. I'm going to say 60, 70, 80, 90. Okay, so 190, 180, 170, and 160. I'm going to draw those in. That's going to make it easier for us. Okay, in 2006, right, when you see a number that looks like this, it usually means a year, and you can guess that it was 2006. Okay? So 2006, there was 156 students in 5th grade. So 156 would be right about here. The school opened in 5th grade. The student population grew the same amount each year before rising its largest class of 2,010 students in 2008. Okay. So this is 210. And if it rose the same amount each year, that means that this is a straight line, right? Oop. The following year, Magnolia lost 1/7 of its 5th graders. 1/7. So we're going to say 1/7 of its 5th graders of 210. Okay, so you're going to multiply 210 over 7 equals 30, right? Right? Yes. So they lost 30 students that year. Wow. Sounds like our school a few years ago. The following year, Magnolia lost 1/7 of its 5th graders. So in 2090, they dropped 30 students. So we're going to go 10, 20, 30 students. We're going to go all the way down here. Okay. A big jump. All right. In 2010, the enrollment dropped to 154 students and remained constant in 2011. So 154 would be right here. And then remained constant through 2011, so that's the same. For the next 2 years, the enrollment grew by 7 students each year. So 54 plus 7 would be 161. And then 161 plus 7 would be 168. Okay. How many more 5th grade students attended Magnolia in 2009 than in 2013? So in 2009, there was 180. And then 2013, there were, what did we just say? 169, is that right? Wait a minute, 54, 154 plus 14, 168. Okay, so 168 equals 12. 12 students. Between which 2 consecutive years was there the greatest change in student population? 2 consecutive years. I would say from 2006 to 2008, right? That's the biggest jump. It's the biggest shift. If the 5th grade population continues to grow in the same pattern as 2012 and 2013, in what year will the number of students match 2008's enrollment? So in 2008, they had 210 students, right? And if they are gaining 7 students a year, so 168 plus 7 plus 7 plus 7, right? How many would we need? 210 minus 168 equals 42, and 42 divided by 7 is 6, right? So we would need 6 more years. So let's see, 13 plus 6 would be 2019. Cool. All right, there's your homework, Johnny's bike trip, and you can answer questions about that. Read those questions carefully. Your exit ticket here is about Harry's hot dog sales. Read the questions carefully and answer them completely. When it says explain, please explain. When it says how do you know, explain. And that's it. Then we're done. That lesson 26 reflection, we're not going to need it because school's ending this week. Okay? And if you want to keep working, your books are your own, so you can keep doing more work in preparation for 6th grade if you'd like. There's a review and more lessons, but this is our last video and our last in-class lesson. Have a very great summer. I love you lots, and tell your little brothers and sisters to have fun with me next year. Okay, bye.